Google just asked this question in the interview. We're given a two-dimensional array and each value indicates the height above the sea level. On the left and top of the matrix, it says the Pacific Ocean. On the right and bottom says the Atlantic Ocean. And the question is asking to return the spot that can goes into Atlantic and Pacific Ocean. If on this location it says the sea level is 5, that means it can go anywhere that is less than or equal to 5. So it can go to 3, and then 2, and then go to the ocean. On the other hand, if you're looking for this spot, you can go to the Atlantic Ocean, and you can go to the 3 and 1 sea level as well. However, it kind of got stuck on here and it cannot continue to go into the Pacific Ocean because it has 4 and then 7 that blocks the way. From the graph, those are highlighted. That means it can go to the both ocean, and we need to return the coordinates of each spot. We can easily come up with a brute force approach that for each node, we perform the search to see if they can go to both Pacific and Atlantic. However, this is not going to pass the test because we have n times m nodes, and for each node, we need to perform m times n search. So the total complexity is n squared times n squared. I'm going to talk about the bottom-up BFS approach. Let's break this problem into two sub-problems, and let's take care of Pacific first. The idea is to initialize the spots that can go to Pacific at first. We know that the first row and the column are attached to the Pacific Ocean, so this is a good starting point. And we continuously find the spots that can go into this area. For example, we find that the sea level 5 can be goes into the sea level 1, so 5 can be included as well. For 6, it can go to 5 and then 1, so 6 can be included as well. For 4, it can go to 2, so 4 is included, but not for 2 since it cannot go anywhere. For Atlantic Ocean, we have those spots that can go into the Atlantic Ocean. Finally, we find the overlap that can go to both Pacific and Atlantic Ocean. As we are doing the BFS search, every time we need to check if our next level is within the matrix and has the higher sea level and is not visited. At first, we can perform the BFS on the edge of the Pacific Ocean. That way, we can find all the nodes that can go into this area. And here's how the algorithm works. Suppose we are starting at 0 and 0. We add it to the queue and visit, and we need to add its neighbors. So at coordinates 0, 1, and 1, 0 is added to the queue and visited. And we pop 0 and 0 from the queue. Now from these two spots, there's no way it can go into. So we pop them from the queue and we keep the visited. And we perform the same function to all the nodes that is attached to Pacific Ocean. And we perform the same BFS function to the spots that attach to the Atlantic Ocean. As we're doing the search, we keep on track on the Pacific and Atlantic visited, and we return the overlap of those two arrays. As we're doing the searching for Pacific, we keep the records in the Pacific visited, same as we keep the record for Atlantic visited. And finally, we return the overlap between those two arrays. And here's the Python script. First, I declare those two visited variables as I said. The m means the numbers of rows, and the n means the numbers of columns. Every time we pop from the queue, we check if the node is already visited. If it is true, then we continue to next iteration. And we add the node to the visited, add 4 direction, going up, right, down, and then left. We check if they're within the matrix, and the next element has the higher sea level, and they are not visited. If all of them are true, then we are moving to the next iteration. We add the node into the queue. And here's how we are scanning the edge of the Pacific Ocean. It is the same as for the Atlantic. And we return the overlap in the result. And my result beats 99% of the users using Python 3. Cheers! If you like this channel, please click like and subscribe. Thank you.